Hey guys, problem 5 here, and in part A we have to find an expression for the area of this gray shaded region. And we know from our polar coordinate lessons that the area bounded by a polar curve is given by the formula 1/2, and then the integral from theta 1 to theta 2 of r squared d theta. And so if we look at the region that's bounded by this curve here, which I've written a subscript under RO to say that it's the outer curve, then the area of this region we're talking about would be this blue region, right? Bounded by the outer curve from theta 1 to theta 2. Okay, so the area of this region, the blue region, using this area formula right here, would have to be equal to 1/2, and then theta 1 and theta 2 are right here, they're given, so 1/2 of the integral from 1/2 of the integral from pi over 3 to 5 pi over 3 to 5 pi over 3, and this time r is just equal to 4, so 4 squared, that's 16 d theta, 16 d theta. Yeah, okay, cool. And if we want to find just the gray shaded region from this area, we want to subtract this area in red right here, right? Bounded by our second curve, right? So we want to subtract this area in red from this area right here. But the area I just shaded in red, this area right here, is given by this formula also, involving this r this time, right? So it's equal to 1/2 times the integral from pi over 3 to 5 pi over 3 of r squared, and r is 3 plus 2 cosine theta squared, and then d theta, right? Okay, cool. And as I said, what we have to do is subtract the two areas, so minus sign right there. Now look, we've got that in common, we've got the limits of integration in common, and d theta here and d theta, so we can combine them into one and write the following instead, and that is 1/2 times the integral from pi over 3 to 5 pi over 3 of 16 minus 3 plus 2 cosine theta whole squared d theta, and this completes part A. Yeah? Okay, cool. So let's move on to part B then. So what does part B say? Part B says this. It says find the slope of the tangent line to the graph of just this curve this time. Yeah, this curve right there at theta equals pi over 2. All right, so this is just asking us for dy dx when theta is equal to pi over 2, right? Okay, dy dx is always the slope of the tangent line, right? At theta equals pi over 2. Now, notice that dy dx, right? dy dx, poor y, dy dx is equal to dy d theta divided by dy d theta divided by dx d theta, right? If you simplify what I just wrote, dy d theta divided by dx d theta, then you will get dy dx, right? And so all we need to do to find dy dx at pi over 2 is evaluate dy d theta of pi over 2, and then evaluate dx d theta of pi over 2, and find the quotient, right? So pi over 2 here, and then pi over 2 here, right? Okay, cool. Now, how do we find dy d theta and dx d theta? Well, recall that in polar coordinates, and by the way, since I've evaluated on the right side, I should evaluate here on the left side, and that way, changed colors too, didn't mean that. Okay, so right there, so this is pi over 2 right here, and so that way I could just get rid of this right here. Yeah? Okay, cool. Now, how do we find dy d theta and dx d theta is the question. We recall in polar coordinates that y is equal to r sine theta, right? And x is equal to r cosine theta. And in part B, the r we concern is this r right there, right? And so then replacing this r and this r here, with what we know r to be, we can get an expression for y and x, right? So y is equal to 3 plus 2 cosine theta times sine theta, right? And then x is equal to 3 plus 2 cosine theta times cosine theta. 2 cosine theta times cosine theta, right? Okay, and we can simplify both of them a little bit. Y is going to simplify to 3 sine theta plus 2 sine theta cosine theta. And recall that this is sine 2 theta. You don't need to know that this is sine 2 theta in order for you to solve part B, but it's a little bit helpful if you knew that. Anyway, here we come. X, the best we can do simplifying x is to write 3 cosine theta and then plus 2 cosine squared theta. Yeah? Okay, cool. And as I said, y we can simplify a little bit more as 3 sine theta and then plus, as I said, this is sine 2 theta. And like I said, you don't need to know this, but it does help a little bit in the next step. Okay. How does it help? Well, now look at dx d theta. Dx d theta is going to equal 3 times negative sine theta plus, and then here we'll do 4 times cosine theta, and then by chain rule times negative sine theta. And so we can simplify this by factoring out a negative sine theta and writing negative sine theta times 3 plus 4 cosine theta. And for y, we have that dy d theta is equal to 3 times cosine theta and then plus cosine 2 theta times 2. So plus 2 cosine 2 theta, right? So plus 2 cosine 2 theta. And this is why it's marginally helpful to know that this is equal to that, because if you didn't, then you'd have to use product rule on this part when you're finding dy d theta. Yeah, okay, not a big deal, right? Okay, cool. And now, finalement, we need to evaluate dy d theta at pi over 2 and do the same with dx d theta. So evaluate at pi over 2 here and evaluate at pi over 2 here. And of course that means that we evaluate the right hand side of both at pi over 2. So there and then there, right? Okay, so pi over 2, pi over 2, right? Okay, and what happens? Well, when we evaluate at pi over 2, cosine of pi over 2 is 0, so this part is 0. And then we've got 2 times cosine of 2 times pi over 2, so 2 times cosine of pi. Cosine of pi is negative 1. So we have that dy d theta evaluated at pi over 2 is 2 times negative 1, or negative 2, right? And then we see that dx d theta evaluated at pi over 2 will be negative of sine of pi over 2. Sine of pi over 2 is 1. So we've got negative 1 times 3 plus, poor 3. 3 plus, and then 4 times cosine of pi over 2 we already said is 0. So 4 times 0, which is just 0. So just have negative 1 times 3, which is negative 3. So we've got dy dx of pi over 2, which is dy d theta of pi over 2 divided by dx d theta of pi over 2 will end up being negative 2 divided by negative 3. Negative 2 divided by negative 3 is going to equal 2 over 3. And this completes part B. So finally, let's move to part C. And here is part C. It's a lot of reading, but it's not saying a lot. It's just basically a related rates question. Given that we have r equals 3 plus 2 cosine theta, it tells us that dr dt is equal to, because it says the distance between the particle and the origin, that's r, right? The distance between the particle and the origin right there, that's r. And so it told us that the rate of change of r is 3 units per second. So that's dr dt is equal to 3 units per second. 3 and units, I guess, is U per second. Got it. Okay, cool. And what it's asking us for is it's asking us for d theta dt when theta is equal to pi over 3. So when theta is equal to pi over 3. Okay, theta equals pi over 3. So this is a related rates question. And what relates theta and r? Well, this equation. So if we take the derivative of this equation on both sides, on the left we get dr dt equals, on the right side, the derivative of 3 is 0. So we get 2 times negative sine of theta, and by chain rule times d theta dt, right? Okay, so we can simplify this a little bit and write that we've got dr dt equals negative 2 sine theta d theta dt. And we evaluate the left side at pi over 3, right? And notice that we are told that the rate of change of r is constant and it's equal to 3. So it doesn't depend on the value of theta. So regardless of where we evaluate between 0 and pi over 2, the left side is just going to be 3. So we've got 3 equals negative 2, and then I evaluated the left side, so I have to evaluate the right side also. So when I evaluate the right side at pi over 3, I'm going to get negative 2 times sine of pi over 3 times d theta dt evaluated at pi over 3, right? Okay, cool. And in this very last equation I wrote, the only thing that's unknown is this guy, so we can solve for it. All right, so I need this space, so let's do this first, and I don't need this either, right? Okay, so let's do this, and what we're after is the only unknown in this equation here. And so sine of pi over 3, remember, is root 3 over 2, so we've got 3. Let me write a little lower. So 3 equals negative 2 times, and it's root 3, what a poor square root, root 3 over 2. But then look at this expression that just says negative root 3. So I'll just write that. So negative root 3 times, and then it's d theta dt evaluated at pi over 3. That vertical bar. Okay, that's better. Evaluated at pi over 3. And since what we're after is this, it's pretty obvious how we're going to get there. We're going to divide both sides of this equation by negative root 3. So we get 3 over negative root 3 is equal to d theta dt evaluated at pi over 3, which is what we were after. Yeah? Cool. All right. This is it for problem 5, and keep watching. I hope you found this helpful. Take care.